In June 1999, a biologist stood at the edge of a release enclosure on a small island in Panama and did something that took 15 years of field work to justify. She opened the door. Two birds stepped out, not seasoned hunters, not adults in their prime, 19 months old and 20 months old, both raised entirely in captivity, both about to enter a world that had forgotten they existed. Within 4 days, there was a kill. Within 2 weeks, the scientists' models were already wrong. And by the time the experiment ended, 14 months later, the island would never be the same. Neither would the woman who opened that door. I'm Tom Marsh, and this is the story of what happens when you return the one thing an ecosystem forgot it, was afraid of, and what it cost to find out. The island has a name that most people outside of ecology have never heard, but inside the field it carries the weight of a century of data. Barro Colorado Island. 85 square kilometers of tropical rainforest sitting in the middle of Gatun Lake in central Panama, surrounded by water on every side, cut off from the continent by a decision made in 1914 that nobody at the time thought was particularly significant. When American engineers finished the Panama Canal, they dammed the Chagres River, the valley flooded. The hilltops, still covered in forest, rose above the surface of an artificial lake. One of those hilltops became Barro Colorado, 15.5 square kilometers of jungle isolated from the mainland overnight. An engineering accident with consequences nobody designed. The Smithsonian Institution recognized what had happened. In 1923, they declared it a biological reserve and began what would become one of the longest continuous ecological monitoring programs on Earth. For the next 100 years, scientists recorded every species, every tree, every animal movement on that island. It became the most studied patch of tropical forest on the planet. And for 100 years, something was missing. The animals that needed hundreds of square kilometers to survive, pumas, harpy eagles, the apex predators that define the architecture of a working rainforest, had been gone since the water rose. The island was too small to sustain them, so they never came back. And without them, Barro Colorado reached a condition that biologists struggled to name. Not exactly balance, not exactly collapse. Something quieter and more insidious than either. Now, before I go further, if you want to understand the full picture of how these recoveries actually work across different ecosystems, species by species and case by case, I put together the Rewilding Complete Pack, which goes far deeper than any single video can. The link is in the description, and you can scan the code on your screen right now. What I'm about to show you about what happened on this island in 1999 is one piece of a much larger pattern, and that pattern is what the pack maps in full. 5 species of monkeys shared Barro Colorado without any reason to fear the sky. Troops of white-faced capuchins spent 80% of their time in the exposed upper canopy, the most visible, most vulnerable layer of the forest, not scanning for threats, not hiding, not responding to aerial movement above them. The cultural memory of danger had been gone for 3 generations. Sloths had reached densities 2 to 3 times higher than in continental forests that still had large predators. The almendro tree, one of the most emblematic species in Central American forests, was dying from within. Ancient trees still stood, some hundreds of years old, but the next generation was nearly absent. Monkey populations were consuming seeds faster than the forest could regenerate them. Bird nests were being raided at rates that were pushing certain species toward local extinction. The forest wasn't dying loudly, it was aging in silence. This is what happens when you remove the top of the food chain for long enough. It's not that the animals at the bottom run out of food, it's that they stop being afraid of anything. And the entire architecture of behavior that evolved over millions of years, the caution, the restraint, the spatial distribution of grazing pressure dissolves. What was left on Barro Colorado by the 1990s was an ecosystem that looked intact from the outside and was slowly hollowing out from the inside. Dr. Sara Barrientos had been studying the island since 1984. She had the trend lines, and they pointed in one direction. Her proposal was precise. Release 2 harpy eagles onto Barro Colorado. The island had a heavily overpopulated prey base, 70 years of baseline ecological data, and a structural problem that could only be addressed from above. The logic was surgical. 2 birds, 1 island. One question that had been building since 1914. The harpy eagle is not a bird that requires introduction in the regions where it still exists. Its name comes from Greek mythology, the Harpies, half-woman, half-bird, creatures of terror that fell from the sky. When Spanish conquistadors first encountered this species in the forests of Central America, they didn't need to invent a name for it. They already knew what they were looking at. Female harpy eagles can weigh up to 9 kilograms. Their wingspan exceeds 2 meters. Their rear talons extend to the length of a human finger and carry a gripping force comparable to the jaw of a brown bear. They have a facial disc of rigid feathers, like an owl's, that channels the faintest sound from the vegetation below directly into their ears. They fly at 80 kilometers per hour through the gaps between trees, short, broad wings built not for open sky but for the spaces between trunks. They are designed to move through a forest like a thought through a mind, faster than anything watching for them, quieter than anything tracking them. But the harpy eagle was disappearing. Its range had contracted by 60% since the 18th century. Fewer than 450 individuals remained in Panama. They breed once every 2 to 3 years. Every adult that died removed years of future generations from the equation. They required primary rainforests, specifically the tallest trees, Brazil nuts, kapok, the trees that disappear first when logging begins. Bringing them back anywhere required first figuring out how to keep them alive in captivity. In 1987, the Peregrine Fund launched a captive breeding program in Boise, Idaho. Temperature-controlled rooms, one-way observation cameras to prevent the birds from imprinting on humans, carefully matched pairs sourced from zoos across the United States, Ecuador, Panama, and Venezuela. Some pairs rejected each other for years. In 2001, the program expanded to the Neotropical Raptor Center in Panama, using outdoor enclosures in actual tropical forest for the first time, closer to the environment the birds were being prepared to re-enter. The cost of raising a single harpy eagle chick through one breeding season gives you some sense of the gap between what we've built and what we've lost. 6,000 mice, 400 live rats, 7,000 frozen rats imported from abroad, 800 live rabbits, 50 frozen stillborn calves. That was food alone, not facilities, not veterinary care, not research staff. In the wild, a harpy eagle makes a kill approximately every 3 to 4 days and catches it herself in the forest, at no cost to anyone. The animal that required the equivalent of a small farm's annual output to survive in captivity needed nothing in the wild except the forest to be there. The program worked. Dozens of captive-bred birds were eventually released across Panama. But the Barro Colorado release was different. It wasn't a release into wilderness. It was a controlled experiment, small enough to monitor every kill, large enough to support a natural prey population, and backed by 70 years of ecological baseline data. The scientists ran the models beforehand. They predicted between 30 and 40 kills in the first year, enough to reduce pressure on the monkey populations, not enough to cause a collapse. Their models were about to meet the island. Guardia was released first, in June 1999, at 19 months of age. Esperanza followed weeks later at 20 months. Both had spent their entire lives in captivity. Neither had ever hunted anything the forest hadn't brought directly to them. Researchers built an acclimatization enclosure on the island, let the birds adjust, and opened the doors when the eagles seemed ready. Guardia hesitated for a few minutes at the entrance, then flew to a nearby tree, sat, looked, and disappeared into the forest interior. The monkeys were curious. They had never seen a bird like this. Some approached, some watched from open branches. In their entire behavioral repertoire, there was no alarm call for aerial threats, No evasive response to large birds. No memory of what this shape in the sky meant. The harpy eagle had found the most unprepared prey population in the Western Hemisphere. Biologists have a term for this: prey naivety. It occurs wherever animals have lost contact with predation pressure long enough for avoidance behavior to disappear entirely. 85 years of safety had produced a textbook case on Barro Colorado, and Guardia and Esperanza were about to walk straight into it. Esperanza was making a kill approximately every 4.5 days. Guardia, every 3.5. First sloths, then monkeys. By the third month, the scientists were no longer observing an experiment, they were watching a crisis, and they had to decide how to respond. They let it run. By the 6th month, the peer-reviewed study authored by Barrientos and her co-researchers had documented 46 confirmed kills by the female and 25 by the male. The capuchin monkey population had declined. The howler monkey population had declined. Spider monkeys had shifted almost entirely to nocturnal activity. Tamarin troops had abandoned whole sections of forest entirely. But the death toll was not the most significant change. The exposed upper canopy had become a kill zone. The gaps between trees had become ambush corridors. The forest floor, previously ignored by arboreal species, had become their only shelter. Fear had re-entered the landscape, not as an emotion but as a physical property of space. Fecal cortisol samples from monkey groups showed dramatically elevated stress hormone levels across every species on the island. The animals that survived were not the strongest. They were the most anxious. They were the ones who hesitated before entering open canopy, who moved through the upper forest in bursts, who kept the branches between themselves and the sky. The trait that kept you alive in 1999 was not power, it was vigilance. And here is where the story stops being a controlled experiment and becomes something else entirely. The Capuchin troops, now spending far less time raiding bird nests because they were too occupied watching the sky, had left an opening. Bird nesting success improved measurably. Pollinators found more flowers. The pressure on almendro seeds eased for the first time in decades. The forest floor was receiving animals it hadn't seen in open numbers for years. The structural reorganization of an entire ecosystem was happening in real time, driven by two birds who had never hunted anything in their lives until 8 months earlier. And then, something that nobody had predicted, the Capuchin troops began following the research teams, not out of curiosity, out of strategy. The monkeys had learned, within months, that the harpy eagles did not attack near humans. So entire troops began keeping themselves within 10 to 15 meters of the researchers moving through the forest, not watching the scientists, watching the sky, and using human presence as a buffer zone. The island's most cognitively complex animals had identified a variable the experiment designers hadn't accounted for and were exploiting it in real time. Nobody had modeled that. And the howler monkeys, the loudest animals in the Americas, whose calls carried kilometers through jungle, were going quiet. A study published in 2006 in the Proceedings of the Royal Society documented what had happened. The howler monkeys of Barro Colorado had rapidly acquired a specific alarm response to harpy eagle vocalizations, distinguishing them from every other aerial sound. The individuals who called at the wrong moment had drawn attention. Over the course of a single generation, quieter individuals showed higher survival rates. Higher survival meant more offspring. More offspring meant the trait spread. The alarm response persisted for months after the eagles were removed from the island. The howlers hadn't just learned to fear, they had begun to evolve. The Smithsonian convened an external review committee. Barrientos presented the data. The panel split exactly in half voting to end the experiment, half voting to continue. The deciding vote went to continuation with monthly reviews. She voted to continue. Her reasoning, recorded in 15 years of field notebooks, was precise. The monkey overpopulation was already causing ecological damage. The eagles were restoring a dynamic the island had lost. The cost was real, so was the alternative. By the end of the first year, monkey populations had stabilized at around 60% of their pre-experiment numbers. Esperanza and Gordia's first two chicks, named Futura and Destino, had already left the nest and were learning to hunt. In August 2000, the Smithsonian announced the experiment's end. The decision to close was not a failure. It was an honest acknowledgement of 3 design flaws that couldn't be fixed without starting again from scratch. The island was too small. There was no ecological buffer zone where prey populations could recover between predation cycles, and there were no competing predators to create the complex pressure gradients a self-sustaining ecosystem actually requires. Esperanza and Guardia were recaptured and transferred to other conservation programs. Futura and Destino entered the Peregrine Fund's broader Harpy Eagle program in Panama. But what the experiment left behind was more valuable than a permanent reintroduction. It left a set of rules. After Barro Colorado, predator reintroduction projects worldwide, wolves, lynx, bears were required to meet new minimum criteria: sufficient territory, ecological corridors for prey population recovery, and a clear pre-agreed exit protocol. The reintroduction of wolves into Yellowstone worked because the ecosystem was large enough. Barro Colorado proved in exact terms why minimum territory was not a practical preference but a demonstrable ecological requirement. 1 island, 2 birds, 14 months, and a dataset that reshaped how conservation biology thinks about scale. In February 2026, the Smithsonian Institution released 2 new radio-tagged Harpy eagles onto Barro Colorado Island. Different birds. The same question. Better technology. The same island, older now, still recovering, still carrying in the behavior of its howler monkeys, the memory of the last time it learned to be afraid. In a 2022 interview, Dr. Barrientos said, "I would do it again, but I would need more island." Esperanza and Guardia didn't just hunt monkeys. They taught an island to feel fear again, and in doing so, they taught us something harder. Ecosystems don't recover on our terms. They recover in ways we can't fully predict, at a cost we don't always get to choose. The Barro Colorado experiment caused the deaths of hundreds of animals. It also saved a forest. The line between those two outcomes is not clean. It was never meant to be. Not everything in this story goes to plan. Not every release works the way the models say it should. Not every ecosystem has enough room to absorb what we ask of it, but the ones that do, and the ones that almost didn't follow patterns that the data has been quietly accumulating for decades, that's the territory the channel lives in. The recoveries that cost something. The ones where the science had to catch up with the animal. There are more stories like this one than you'd ever imagine, and I have many more to tell you. If you were on the Smithsonian Review Committee in 1999, knowing everything you know now, would you have voted to continue the experiment or to pull the eagles out? There's no clean answer, but I want to know where you land. Leave it in the comments. And if this is the kind of story that matters to you, share it with someone who needs to hear that the news about the natural world isn't only what it seems. Subscribe, and don't miss what's coming next. I'm Tom Marsh. Thank you for watching.